Hi, I'm Keenan Casey for TutsPlus.com. In this lesson of Computer Networks Distilled, we'll be looking at the Internet Protocol Stack. The Internet Protocol Stack is the most common stack used. It's the one that powers the Internet. As you may recall, Internet Protocol Stack involves 5 levels, 5 layers. The top level is the application layer. Under that is the transport layer. The network layer is underneath the transport layer, and the link layer is underneath that. At the bottom level is the physical layer. We're going to take a look at each of these in a little bit more detail and talk about one important property of each level. The important property I'd like to start with is whether a layer is end-to-end or point-to-point. An end-to-end protocol is used only at the endpoints of communication sessions. This is implemented and therefore active only on the endpoints. A point-to-point protocol, on the other hand, is used on every relaying device, so it's implemented throughout the whole path on the endpoint nodes as well as the intermediate nodes. This diagram illustrates the difference between end-to-end and point-to-point protocols. Notice that only the client and server are running the end-to-end protocols, whereas all of the nodes, all of the computers, the routers and the computers in the network are running the point-to-point protocols. In the context of the Internet Protocol Stack, the top 2 layers, the application and transport layers, are end-to-end layers, whereas the bottom 3, network, link, and physical, are point-to-point. Let's jump in and look at each of these layers in a little bit more detail. The application layer is an end-to-end layer. It's the layer that provides communication services directly to the user. These are things like the web, email, file transfer, voice over IP, among many others. These are application layer protocols that provide services directly to the user. Underneath the application layer is the transport layer. The transport layer is another end-to-end layer. The transport layer has one major function, and that is to hide the defects of the network layer. Imagine that we have an application layer on one computer that wants to talk to the application layer on another computer. So there's an original message that the application layer will send down to the transport layer. When the transport layer receives this, however, it's going to have to send it over the network layer, which may lose, duplicate, or reorder messages that are sent to it. Additionally, the network layer may impose a smaller packet size than the original message was. In that case, the transport layer may have to break up that original message into smaller chunks. In this case, it's going to break up the original message into 5 chunks. Now, when these are sent over the network, they may be lost or duplicated or reordered. Notice at the recipient, the transport layer doesn't receive packet number 2. It receives the packets out of order. Packet number 4 is corrupted, and we receive 2 packet number 3s. So it's the job of the transport layer to be able to recompose that message and pass it up to the application layer, even in the presence of these errors. The 2 big transport layer protocols in the Internet Protocol Suite are TCP and UDP. Under the transport layer is the network layer. The network layer, basically IP and routing protocols for the Internet Protocol Stack, is a point-to-point layer. The main functions of the network layer are to provide addressing, that is, to provide unique identification to all of the hosts in the network, and also to route among those nodes. Routing basically means, given any 2 points, find me a good path to get from point A to point B, even though it may be across multiple nodes in between them. The link layer is also a point-to-point layer. The main functions of the link layer are categorized under the data link methods and the medium access control methods. Data link means that we are providing frames, that is, we're providing discrete chunks of data for sending across the links. The link layer may also provide error control. That means that it will check packets to confirm that the packets were not corrupted during sending. And additionally, flow control may be provided, and that means that we will prevent a receiver from being overwhelmed by a very fast sender. Medium access control basically allows a channel to be shared fairly. And the link layer is responsible for providing these services. At the bottom is the physical layer, which is also point-to-point. The main function of the physical layer is really the transmission of raw bits, basically moving bits from one node to another over electrical or magnetic means. So in this case, electrical and mechanical specifications are going to come into play. So this has been a brief overview of the Internet Protocol Stack. We looked at the application, transport, network, link, and physical layers. This will be the outline for the remainder of the course. I'm Keenan Casey for TutsPlus.com. Thank you for watching.